welcome to my channel where I explain AP Physics 1 content hopefully in a very simple and easy way to process. My videos are for people who desperately need help, and today we'll be talking about Unit 1 overview and kinematics, which is just a fancy word for describing motion and how things move. So the first concepts I'm going to touch on are going to be position, distance, and displacement. And along with this, first I'm going to introduce you to something called a reference frame. And a reference frame is basically your point of view or home base. So imagine you're standing still and you're watching a monkey move around. Well, in this scenario, you're the reference frame. Now, on a number line, imagine that monkey walks 5 steps forward and then 5 steps back. How far did the monkey walk? Well, in this case, it would be 10 steps. We just did 5 plus 5. But if we have that same situation where it walks 5 steps forward and then 5 steps back, what's its displacement? Well, in this case, the displacement would be 0. And this is because the monkey ended right where it started. And displacement is all about comparing where you started to where you ended, not the total distance you traveled. Now, let me say that again. Distance is just how far you walked, and displacement is how far you are from where you started using the ending point as a guide. Now, another thing to note is that distance is going to be positive and displacement can be either negative, positive, or even 0. And another thing to differentiate between the two is that displacement has direction. Because displacement has direction, this makes it a vector. And a vector, kind of like the guy from Despicable Me, is something that has both magnitude and direction. Magnitude being how much and direction being which way. Distance, on the other hand, is a scalar, meaning that it just cares about quantity and not direction. Now, a helpful equation to help us determine displacement would be this one right here. Delta x is equal to x final minus x initial. In this case, x just means position and delta x just means displacement. Keep in mind that your position just means where something is, like located on a number line. Now, I'm going to talk about velocity versus speed. And while they may seem the same, they aren't. So, say you run 300 meters in 60 seconds. Well, to find your speed, we just do distance over time, which would be 300 over 60, and that would give us our speed. Now, let's take this same scenario, but this time try to find velocity. Well, because we ran in a circle, our displacement would be 0. So, we use the formula for velocity, which is displacement over time, and we get 0 meters per second for our velocity. We have speed, but no velocity. What does this mean? Well, if you have speed, but no velocity, it tells us that you're moving, but your direction is constantly changing. Like if you're running in a circle, which in this example we were. So that is what makes velocity different. It includes direction, while speed doesn't. This also means that velocity is a vector and speed is a scalar. Now, the next thing I want to talk about is acceleration. Basically, acceleration is velocity that is changing. And the acceleration for acceleration would be acceleration is equal to delta v over delta t, or changing velocity over delta v over delta t, velocity in time. So, say we go from 0 meters per second to 20 meters per second in the span of 4 seconds, and we want to find our acceleration. Well, we'd have to get our components, which would be delta v and delta t. So delta v is equal to 20 minus 0 because that is how our velocity has changed, and that just gives us 20, and our time is given to us, which is 4. Now, if we plug this into our acceleration equation, we get 5 meters per second squared as our acceleration. Another thing that Unit 1 covers is graphs. And there are multiple graphs like position over time graphs, and I think that these are pretty important to know. So I made a whole separate video about that, on how to read these graphs and what exactly their slopes mean and things like that. So go check that out. So I know that was a lot of information if you're just starting out, but let's go over some takeaways or things you actually need to know. First takeaway is that distance is just equal to how far, displacement is how far plus which way, speed is how fast, velocity is how fast plus which way, And acceleration is how fast velocity is changing. So with that, let's do a little example. So at 2 meters per second, you're accelerating for 3 seconds at 2 meters per second squared. What is your speed? Well, we can use one of the kinematic equations. And these equations I also went over in a separate video. But there are multiple ways to find velocity, and this is one of those. So that equation is going to be final velocity is equal to initial velocity plus acceleration times time. And we plug in our values, and we do 2 plus 2 times 3, and we get 6 meters per second as our velocity. Now, this is a very brief overview, and I have other videos going more into depth, but just know we're going to get 5s. It's going to be fine. Anyways, go check out my other videos. Thank you.